Hello everyone. Today we will learn about AWS Single Sign-On, in which we will see what exactly is AWS Single Sign-On, how does it works, what is SAML 2.0, and much more. At the end, we will have a demo to integrate AWS Single Sign-On with Azure Active Directory. That is, users in Azure Active Directory shall be able to access AWS resources using their Microsoft's credentials based on what kind of permission sets you provide to them. So let's get started. Nowadays, with multiple websites and applications, we have to deal with multiple passwords. And most of the time, we end up reusing them, which may lead to password reuse attacks. Similar things happen in any organization where the employees have to make note of passwords for different infrastructures and tools they use for day-to-day work. They too end up having the same password for all the resources. This can compromise the security for any kind of organizations. And on the back end, information security teams are coping with multiple authentication schemes and lack one source of truth. So what exactly is the solution for this problem? This is where AWS Single Sign-On comes into pictures, providing a robust foundation for the enterprise to maneuver beyond passwords and protect their businesses. So what exactly is AWS Single Sign-On? AWS Single Sign-On, which is also called as AWS SSO, is where you create or connect your workforce identities in AWS once, and then you manage access centrally across your AWS organizations. So AWS organizations basically give you more granular approach to provide access controls to such kind of users. You can choose to manage access to your AWS accounts or cloud applications via AWS Single Sign-On. You can create user identities directly in AWS Single Sign-On, or you can bring them from your Microsoft Azure directories or any other standard-based identity providers such as Okta's Universal Directory or Azure Active Directory. So now we will see exactly how Single Sign-On works and how we implement it on top of AWS. So for this, we just have to enable AWS Single Sign-On in any of the AWS region. Say in US is Northern Virginia, we choose. Then once you enable the AWS Single Sign-On, you choose your identity source, be it AWS Single Sign-On itself, which should be pre-configured for you. Or if you want to change your identity source, then you have other options like Active Directory, SAML 2.0 identity provider. Once you choose the identity source, now you just have to manage your permissions centrally for your AWS accounts, AWS applications, or say SAML applications. Once everything is set up properly, now the users can get single-click access with AWS Single Sign-Ons to any of the AWS resources based on the access provided or based on the permission sets. AWS Single Sign-On basically supports identity federation with SAML, that is security assertion markup language, with the version 2.0 for its executions. So what exactly is SAML 2.0? SAML 2.0, which basically stands for security assertion markup language, is mainly a standard for users to logging into different applications based on the sessions in another context. The SAML 2.0 has significant advantages on logging in via username or passwords. For the three different things that we have here is we don't require any kind of credentials, no requirement to remember or renew passwords, and no more weak passwords with SAML 2.0. We'll understand how exactly things happen in the backend for SAML 2.0. So in the first, the user accesses the portal via an application start URL provided by the organization. Now the application redirects the user to identity provider for authentication, which mainly we call as authentication requests. The identity provider constructs the authentication response in the form of XML document, which consists of the email address and the password of the user. Then it signs it using X.509 certificate, which is later provided to the service provider. The service provider basically knows identity provider as a trusted identity or trusted entity, retrieves the authentication response and validates it using the certificate's fingerprint. This is how the identity of the user is verified, and he or she is then authorized to access the application based on access control. So how does SAML 2.0 can be used for API access in AWS? That we will see in next slides. So let's assume we need to provide access to users for copying the data from their personal computers to a backup folder. However, the user don't have direct access to AWS, for which you build an application which is in the backend, which in the backend reads and writes objects in an S3 bucket. This is where temporary federated logins come into picture. So this is the architectural diagram, how exactly SAML 2.0 works, in which the client app first makes request to the identity provider. The identity provider then authenticates the user. It generates an IDP, sends a client or SAML assertion. Then the client app calls AssumeRoleWithAPI to the security token service that is on the AWS side, which basically provides temporary credentials after assuming the role with SAML. Once this temporary security credentials are assigned to the client app, then it can successfully access AWS resources based on access control it has been provided for a specific amount of time. Now we will see what is the difference between AssumeRoleWithSAML versus single sign-on. So in AssumeRoleWithSAML, we have to maintain a third-party identity provider login portal that will check our identity with identity store and return to us the SAML 2.0 assertion that is sent to security token service. And we get back security credentials, thus we are connected to AWS. However, let's say if we have multiple accounts on AWS, then we are required to set this same AssumeRoleWithSAML process for each and every single account, and top of it, we need to manage the login portal as well. While in AWS Single Sign-On, our browser interface will log in through the AWS Single Sign-On's portal, which in return we don't have to manage. And Single Sign-On is already integrated with the identity store, which is SAML 2.0 compatible. So we don't have any extra setup to do for the same. Here, the advantage is that we can set up this process only once for multiple accounts we want to connect to, with further access control via AWS organizations and policies, removing any kind of overheads. So now let's jump into the demo. Now for the demo, hop on to AWS Management Console and make sure you are signing into the Azure portal on the next tab. On AWS Management Console, search for AWS Single Sign-On and click on AWS Single Sign-On service to open it. Since we are going to set up step-by-step integration of AWS Single Sign-On with Azure Active Directory. At the first step, we will enable and set up AWS SSO. So let's get started by clicking on Enable AWS Single Sign-On. This will take a couple of seconds. In the second step, we will basically configure enterprise application in Azure Active Directory. Now we have successfully enabled AWS Single Sign-On. Since we are using Microsoft Azure Active Directory, we will have to choose the identity source according to that. So we'll click on Choose Identity Source. Here you should see the error because Single Sign-On takes a while to be enabled. So let's try with refreshing the page. And I think so it should be, yeah. So here we are. Here you can see by default, the identity source is AWS Single Sign-On and the authentication method is also AWS Single Sign-On. Since we are using Microsoft Azure Active Directory as the identity source, we will change the identity source by clicking on Actions. Now click on change identity source. Since we are not using AWS managed Microsoft Active Directory or Active Directory connector, also our Microsoft Azure Active Directory lies within external identity provider. So we will select external identity provider here and click on next. Since AWS SSO serves as a service provider, we have to provide some certificate or a metadata file which consists of AWS SSO certificate and metadata details with which the Microsoft Azure Active Directory or the Azure side will trust AWS SSO. For this, we will download the metadata file. Once the file is downloaded, we will go to the Microsoft Azure portal and click on Azure Active Directory. Here you shall see all the features provided by the Active Directory on the left side. We click on Add and click on Enterprise Application. Here we will search for AWS Single Sign-On and click on it. We will create AWS Single Sign-On provisioning, which will take a couple of seconds to create. For the timing, we will check on AWS SSO side what other configurations we have to set up. So here you can see similar kind of metadata file AWS also requires to trust the third-party identity provider or say Azure on the other side. So back on AWS Single Sign-On, it should be created by now. So now we will see, we'll click on Single Sign-On. Since we already know that AWS Single Sign-On supports SAML authentication, here we will select Single Sign-On method as SAML. Now here you can see we have to upload a metadata file. So we will upload the same metadata file that we downloaded earlier on the AWS console. And click on Open, click on Add. So the metadata file consists of various kinds of details, out of which it consists of identifier, that is entity ID, and reply URL, that is assertion consumer service URL. We will save these basic SAML configurations. And once they are saved, a new federated metadata file should be created on Azure's end, which we can see under SAML signing certificate. Here, the Federation metadata XML will download this file so that we can use this file to upload on the AWS side. So now, once it is downloaded, we'll hop back to the AWS SSO console. And here under identity provider SAML metadata, we will choose the file that we just downloaded from Azure portal. Click on Open and we will click on Next. To confirm the change, we have to type accept. So we'll type it and click on change identity source. Once we have changed the identity source, now we should enable automatic provisioning. But before that, we should add users in our Active Directory. So we'll be back on Azure portal and click on users and groups. Here we will click on add user or group. Since no user has been selected, we will select the only user, which is nothing but the root user of the Azure portal account. I will add this, select it, and assign it to the Active Directory. Now we will hop back to the AWS side and enable automatic provisioning. This will generate a SIM endpoint and an access token, which we have to provide on the Azure side to establish the connection. So what basically SIM stands for? So SIM basically stands for System for Cross-Domain Identity Management. The main goal of SIM is to securely automate the exchange of user identity data between your company's cloud application and any service providers such as enterprise SaaS solutions. So we'll just copy the SIM endpoint and hop back to the Azure portal. Here, now click on provisioning. Under provisioning, to automate the identity lifecycle management with Azure Active Directory, we will click on Get Started. Under provisioning mode, select automatic, and here under the tenant URL, you have to provide the same endpoint that we copied from AWS SSO side. Now for the secret token, we will copy the secret token from AWS SSO side and paste it here, and then we will test the connections. Now I have copied the secret token, which I will paste it here and click on test connection. The connection has been successfully tested. So now we will save this configuration. Once this configuration is saved, we will hop back to AWS Single Sign-On side. So this is set enabled properly. The configuration is saved properly. So now we will click on AWS Single Sign-On. And here for starting the provisioning, we should click on Start Provisioning. It should take a couple of seconds to start the provisioning and populate all the users that are in the Azure Active Directory. So after refreshing, we should be able to see that the provision cycle is completed. Here you can see that initial cycle completed and we have one user in the Azure Active Directory. Now we shall hop back to the AWS side and check whether the same user that is in the Azure Active Directory should have been populated under users on AWS side. Here you can see the same user which has already been here. So now we should create the permission sets for this user and assign this user to the AWS account that we want he or she to access it. So on permission sets, click on permission sets. Here we will create the permission set, basically providing what kind of access we want the user to have on our AWS account. So we'll create a permission set. We will go for custom permission set. We'll click on next. We'll go for AWS managed policies, and here search for power user. Search for power user, and here select power user access from the AWS managed policies and then click on next. Provide the permission set name as power user access. We won't provide any description for now, and keep the session duration to be default, that is 1 hour. Now click on next. After reviewing, we will click on create. It should be created in a couple of seconds. And the permission set power user access has been created successfully. Now we shall assign the user to the AWS account that which we want the user to access it with the AWS Single Sign-On. Here we have only one AWS account. So we will select this account, click on it, and we'll click on assign users or groups. We will add the same user and click on next. We will select the power user access permission set that we just created and click on next, and we will submit this. And once we have re-provisioned your AWS account successfully and applied the updated permission set to the account, now we should hop back to the Azure side to enable a small permission which comes under single sign-on. So under single sign-on, check for attributes and claims and click on edit. Here under unique user identifier name ID, click on it. Under source attribute, change the source attribute to user.mail. We are making this change so that if you don't want to get an MFA invalid credentials in further steps, you will have to do this change, which is a smaller one, but which will save you from not getting any kind of errors in future. Once this is done, we will save this configuration. Once the configuration has been completed, we will hop back to the AWS console. Here, we'll click on dashboard, non-dashboard. Once everything is set up, we will now test for the setup. We will copy the user portal URL with which any of our users will be able to sign in to the AWS account with single sign-on. Now, this URL should at first redirect you to the identity provider to provide the credentials. That is nothing but the Microsoft credentials. So here we will provide provide the password. And to stay signed in, we'll click yes. At the first time, it will verify your identity with a multi-factor authentication. So you should get a MFA code on the email address assigned to your Microsoft ID. I should be able to get the code. I received the code 9551463. Verify the code. And that's how you should be able to sign in to your AWS account with your Azure credentials. And here you can see you have the access to the AWS account with power user access for management console as well as for the command line or programmatic access. Now we will click on management console. This should sign in you into the AWS management console. And this user should be able to access all the services other than IAM, since power user access only restricts you to use identity and access management service in AWS. Other than that, almost you have administration access for all other AWS services. So we'll check this by going on S3, simple storage service. Here you should be able to create a bucket, view what kind of buckets are there, and perform all other actions which basically a root user can do. But after searching IAM, this user should not be able to access the IAM service, since it has only power user access, and IAM service access is restricted for this user. So you can see that you do not have permissions required to perform this operation. This way, we have successfully implemented the integration between AWS Single Sign-On and Azure Active Directory. I have mentioned everything that we have implemented in this video in the blog case study integrate AWS Single Sign-On with Azure Active Directory. Here you shall find all the other details that you want to know about AWS Single Sign-On and how it works, along with the implementation setup and steps. You should be able to follow this blog. I will provide the blog link into the description. Finally, thanks a lot, and reach out to me for any other queries. Thank you again.